This video is going to cover what you need to do for Program 6. Program 6 simulates a checkbook balancing program. Here's an example of a statement that you might get every month for a bank account. And you'll see there are debits. These are the details here. And you also see a summary section. So what you're going to have is a menu-driven program in which you will be prompted what type of transaction each of these details are. So I have, for example, if you enter 1, it's a deposit. Then for that transaction, you'll also be prompted for the transaction type. However, you will not be printing these details out. All you will be printing out is this summary section. So you would be prompted for the opening balance and the closing balance. And then in a loop, you will be adding together all of the credits and all of the debits. After the loop, you should then take that beginning balance and add together all of your credits, which is an accumulator, and all of your debits, which is a different accumulator, and you will get an ending balance. I have here some test data, so I'm going to execute the program that's already written and see what happens so you know that how your program should work. So when your program first runs, you will be prompted for your beginning balance. So I'm going to look at this test data. It's $556 is the beginning balance. Next, you'll be prompted for the ending balance, $833.40. And here is the menu. 9 is the exit for this menu. And this is the sentinel value. 9 is the sentinel value for a loop. So what's going to happen, there are many transactions. So we want to continue looping until they're done entering the transactions. When are they done? When the user keys in 9. If the user keys in a 1 for deposit or 6 for interest, then those are items that are adding to the balance. However, you do not have to add to the balance. What I want you to do is add to an accumulator. I called my accumulator total credit. So we're crediting more money to the bank account. 2, 3, 4, 5, 7, and 8 are all payments or debits. So if the user chooses one of those, you will be accumulating to a different variable, say total debits. So with each transaction, all you're doing is getting that transaction amount and adding to the correct accumulator. Let's do a couple of these. So the first one was a web payment. I'll enter 4. And that transaction amount is $153.50. Okay. And the second transaction was a deposit, and that transaction amount is $555.90. And the third transaction is another web payment, $425. Just for demonstration purposes, if the user enters an invalid code for the menu, they're going to get this, followed by another menu. Okay, so this is actually in the default part of the switch. If they fall to the default part of your switch statement, they're going to get this error message, and then you just, every time we exit the switch, we bring up the menu. So this time we're all done with our transactions. I'll enter the right value. I entered the correct final balance. And notice that it says your account is not balanced. With every programming language, not just Java, there can be a rounding error with doubles. And in this case, yes, it created a rounding error because it's got 1/1,000,000th here, and this one doesn't, and so they're not considered equal to each other. So I took a look at some options in Java to resolve this rounding error, and one of them was to use Big Decimal, which is a class. But I thought I'd go ahead and use this, and it worked out well. So we're going to use this method math.round, we're going to take our expression that's calculating the ending balance, and we multiply 100,000 within the math.round, and then we're going to redivide it by, I believe that's 100,000. Okay, so here is the statement. My variable calc balance is the calculated ending balance. The calculated ending balance, I said, was the beginning balance. I added the accumulator for credits. I subtracted the accumulator for debits. This executed, and this is what my calc balance was. This is what I entered. So I went ahead and changed this to use that math.round. And you will probably have to do the same thing. I took this whole expression, put it inside this parenthesis. So here's what we're rounding. And because we multiplied it by 100,000, that one goes way to the back and gets truncated when we divide it again. And that did work. So let's go ahead and run it again using this for calc balance instead of the earlier expression. Using the same data, I got 556 and 153.50, 556, 833.40, I believe. And the first item was a web payment for 153.40, was it? 50. Second item was a deposit. Tested this many times, so I should have it memorized. And this one was 125. I'm all done, so I'm going to hit 9 to exit. Notice, evidently now, it did work out because it says it has balanced. I'm not getting that error. And we're showing then this summary data when it is balanced, the beginning balance, how many credits, how many debits, and the ending calculated balance. I'm going to run this program one more time, but put the incorrect ending balance into the input. So let's say I think that I have 800 in the account. Let's quickly put in these amounts. And notice that 833 is the actual correct final balance, and 800 is what I deposited. You do not need to output these here. This was just for my demonstration of the rounding. But it does say your account's not balanced, which is correct. It says that my actual balance is greater, which is true. 833 is greater than 800. And it's telling me to do an adjustment of 33.40 to the account. And the actual ending balance is 833.40 and not 800. Okay, and then there's the summary data similar to what we had before. Whether the balance at the end is balanced or not, I want you to put this summary data here. So I hope you enjoy writing your program, and I look forward to seeing them.